So I'm going to start with the first session we have scheduled in track 2 today. Live coding, building a unit testing library like Pytest. So we have Bhavani Ravi with us today. She is an independent software consultant and the founder of The Learning Dev. Please welcome her on stage.
Hello, hello. Hello. Good, good, good. How are you all feeling? Okay, so energy is up. I don't have to do anything about it. Like the introduction, I'm Bhavani Ravi, and I hate ChatGPT. Oops. But before I tell you about the things I hate, let me tell you about the things I love. I'm an independent software consultant, which means I love technical problems. Yes, I can code. And that's how I've been coding and falling in love with Python for the last 8 years. And I also love teaching other people to code, and that's how I started this community called The Learning Dev. So those are all the things I love. And for today, what I'm bringing you is live coding. Yes, I'm going to switch to VS Code very soon. A unit testing library, like Pytest, from scratch. Yes, and this is for fun, purely. If you go take this, go put it in your production. I'm not responsible. It's up to you, okay? And why? Because you can. Because we are all Pythonistas, we can. Um, Not just that, this Richard Feynman's quote is where it all started. What I cannot create, I do not understand. I always like breaking open the black boxes and going deeper into that. But it's not just Richard Feynman's doing, it was also someone else. This PyCon talk, okay, this is why I need Wi-Fi, and it went down. All right. So there was this PyCon talk in PyCon Berlin 2022, which showed me how to write ORM from scratch. The talk is on YouTube. You can go and watch it. So which got me to write my own Flask, and I did it almost 3 years ago, and that is now outdated. Flask has evolved, but I could write it. So that gave me a boost. And what was next? Pytest. So when I started doing Pytest, or whenever you want to build something from scratch, uh, you have few options to do it. The basic option is reverse engineering. Going back, figuring out how they have done it, and you build your own version. And the primary way of reverse engineering is to reading the source code. So if it was for me, that's what I did for Flask. I went, read the source code, recreated it, or at least parts of it. So reading the source code, except there was one problem. Pytest, the source code from GitHub, it's huge. It's really, really huge. And that was me. No, not happening. I'll tell you why. Because this has about 130K lines of code. That's almost 1 lakh plus lines of code. And the earliest commit was 2007. 3 more PyCons and it'll be 20 years old. 6,000 plus PRs. The slide is a little outdated. It's 7,000 now in just 1 year. I'm like, how am I going to ever go through this? TLDR, it's very hard to reverse engineer. Impossible. So what's the next best option? Is to go and ask ChatGPT or GitHub Copilot. Remember I hate ChatGPT? Yeah, we are coming to that slowly. In 2023, ChatGPT didn't have an answer for this. And that gave me a boost. If ChatGPT can't do it, can I? And that's exactly what I did. If I were to build my own, I need to have all these parameters, test runner, parameterized test case, and assert traces if you've used Pytest, and fixtures. If I can support all these features, I'm done. I can call myself, I've done a Pytest library from scratch. And that's exactly what I did. The next slide is going to be blank because I don't have internet. Sorry. So on Pytest, I went ahead and built one. It's on my GitHub, Bhavani Ravi. This is the code. I written it, went to PyCon Australia and presented it. This is a live coding again. This was the same talk I was supposed to give now, except something happened. So I presented it in PyCon Australia last year, except something happened between then and now. It was ChatGPT, the culprit, who stole my code. Now if you go to ChatGPT and ask it to write a Pytest from scratch, it does, except it's my code. I'm like, what? What am I going to do for PyCon India now? But I'm a Pythonista. I can innovate. So we are still going to live code. We are still going to do a unit testing library, just not like Pytest, but from scratch. Ready? Okay, here's what we are going to do. We are going to do own unit test. Okay. Now for the question to you. How many of you here have used unit test in Python? Yeah? How many of you like Pytest over unit test? Yes, but we are going to go back to our roots, the standard library, unit test from scratch. So for this, okay, before you guys ask, is this visible to everybody from the back? Yes? Good, great. Now let's start this. Every time I teach Pytest or every time I teach something in Python, we always start with our basic calculator. So this is my base program. Everybody hope here understands this. So this is my basic calculator. Next, and I'm in the wrong file. See, things like this happen in live coding. So here's our basic calculator. Let's write a test case for this. And how do we import like standard library unit test? Okay, you're all awake still. Okay, good. So let's do that. And here's the test case that you write out of Python. From unit test, import test case, and then I import my calculator, Pytest is there, blah, 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 and you have your asset traces here, and you have your subtest here. How many of you use subtest extensively? Yeah, there's no parameterized test case in standard library, but there is a subtest which you can do by looping over a bunch of items. So thanks to Django, I do all of this and Pytest. So the beauty about standard library Python unit test is you can run it as basic Python using main, or you can also use Pytest and do this, right? And to prove that I'm not cheating, I'm just showing you the code, I'm going to change something and hope it fails. Yeah, it fails. So everything is intact so far. Here we have one failure. Let's put it back. Now, this is still everything standard library, everything Pytest provides. We still have to write our own. So what would I do is go here, change this to from own unit test. This is going to be my own version of unit test, which we are going to build together, and import the same class, which is test case. Now, rather than using the standard library test case, I'm going to use this test case. And if I run the test cases again, it's going to fail terribly, saying what own unit test, what test case, nothing. How many of you here done TDDs, test-driven development? Yeah, we are going to do a craziest version of it. We have the business logic, we have a test case. Now the test case fails, so we're going to go back and build a testing library. How cool, wonderful. Only programmers can do shit like this. So let's start by writing the test case class. That's all I need for now. Let's run this, and it's going to give me a bunch of other errors. So here it is, giving me a bunch of other errors. It's saying, what assert equal? I don't know what that is. What subtest? What assert traces? None of this I know. So give me something. So let's go ahead and give it some meaning. I would also like to open this in, right, so that we know what we are working with. For assert equal, we'll usually pass two parameters, correct? So let's write that function, def assert equal, and to this we'll pass x and y. And if it's not equal, what error it should raise? Assertion error, exactly. So we'll just do an assert here, x equal to y, and our assert equal is done. So I'll close this. Now you get the gist of how to read the signatures and how to write new functions. Let's bring this back. At least half the errors are going to go away. There is still one more error, but we will come to that. Next we have subtest and assert traces. Let's spend some time here. Here on assert traces, what is this in Python construct? Context managers. Are you guys aware of that? Yes, context managers, have you seen it in a class form? How it looks? It has an enter, it has an exit. So that's what we are going to write next. So let's write this assert races function. And what is assert races called with is an exception, correct? We usually call this assert races with an exception class. So let's write that self, exception, and we have to return something. What we are returning here is the context manager itself, which we don't have yet. Let's write one. This context manager is going to look something like assert context manager, and to this I will pass the exception. So we are still not done. It's going to ask what assert manager. I don't know what assert context manager is. So let's write that. To not waste your time, I have also stubbed it. So I think it's called subtest context manager. Let's change this to assert context manager. And to this, we will be passing the exception object, and we will be preserving it. Equal to exception. Great. Now, I pass the exception, register it. Here, if it raises the exception, we should capture it. It's all good. If it doesn't raise the exception, then we have to raise an assertion error. Confusing? Okay. What happens is the code in here executes, and then it either raises an exception or doesn't. It goes two ways. And all of that you can capture in the exit method. Right? When the context manager exits, it will say whether there is an exception or not. So what we are doing here is, if this exe type, this is the block which raises or doesn't raises an exception. If this is not an exception type equal to self.exception, as in whether the registered exception is of that type. If it's not, then raise an assertion error saying if I'm expected self.exception, but I got exe type, right? So now let's run this. We are still nowhere near, at least something is working. Now here you can see it's saying assertion error. I'm expecting zero division error, but I'm getting attribute error. We'll come to that attribute error in a bit. Let it all fail now. Next, let's also write the subtest. Subtest, I'm not going to give it a logic yet. I'm just going to give it the stub so that it will stop failing out. That's for next PyCon maybe. Self and all the keywords, and return subtest context manager. I'll go back and fill this context manager because now we are all pros in writing context managers. So that's my subtext context manager. Like I said, I'm not going to give it any features. So let's go back and giving subtext context manager and all the arguments in the world. Wonderful. Now it's all attribute errors. We can deal them all in one go. Why is attribute errors happening? Because something called calc is missing, and that calc is at the setup class function. If you've used standard library, this is something we know, like all your setup instructions goes in setup class and you write a tear down, and unit test takes care of calling them on the go. Like when you run the test case, unit test takes care of it. But here somebody has to do the job because you're the one building it. The closest way I could find to do it, because I'm not building anything fancy, is to have an init method inside my test case class. And this test case class will call all the setup function. So setup class, that's all I need for now. So yay, no errors, amazing. No, not impressed? Yeah, I was not too, because nothing is running. At least we don't have errors. Why do you think this is happening? What's going on? I think it's right there because the moment you add an init, Pytest will say, I don't care about it. Like, I don't give anything about this particular class that you wrote because you wrote in it. And I kind of went and tried to find a way around this, but I couldn't. And this is the best I could do. So I have to somehow enforce Pytest to actually see and understand the worth of the the own test library that I wrote. And to do that, thankfully, Pytest has a way. It's called writing hooks, and that's what we're going to do. This conf test that you write with along with your test cases. So in conf test, you can write hooks for Pytest to understand things. Uh, this is going to be hard to type, so I'm going to have a stub for this. I'll also explain this. So this particular function is called make item collection function. So this will collect all the custom items, right? So to this, I'm going to only look at the classes and whether it's a subclass of my custom test case. So my custom test case is imported here, and to this hook implementation, I'm only going to bother about the classes that are of that test case type. And I'm going to have a custom test collector, which is going to collect my test cases. And how does it do it? Now, inside this custom test collector, it bothers about the class, and we get all the items of the class, find out whether it's a function, whether its name starts with test underscore, and then we will yield that item with that function object, saying that this function is a valid test function, doesn't matter whether I have init or not. This code is a little complicated to even write or to grasp in a minute, just that we are registering the class as a proper test case class and then going through each function and then injecting that into Pytest to recognize it. So now if I go back to Pytest and run it, it runs it. Oh, I actually miss this every time. So this problem is because in the context manager of my own Pytest, if something is wrong, I have to raise an assertion error. If nothing is wrong, you have to return true. Then this zero division error will be suppressed. So now we have all the test cases done. We have removed standard library, injected our own class, and we have all the test cases passing. Now still, I'm not tricking you, it's actually working. I will remove something and then add it, and it still fails. It's Pytest doing the job with our test class. Amazing. Is this done, or do you guys want more? Dividing by 0 is already here. You want to try one more? We can do that. Mm-hmm. Okay, we'll get to that if I have more time, but I have something more. We only covered the Pytest part of it, but we have left an elephant in the room, which is Python's inherent capability to run your Pytest, right? You can remember when I said you can do this in Python? Yeah. So if I run this, 0 tests ran because it's my test case class, and Python has no clue how to go about that. So we have to now go and give this functionality to our own test. So from own unit test, import main, and again, back to square one, it's gonna say, main is what? Main, nothing, I don't know what you're talking about. So let's go and fix that. Def main pass, still not there. Now, oops, I don't know where that is coming from. Yeah, still nothing. Now help me out here. Do you guys know how do we go about this? We have to find out all the test classes that is written by extending our own test, right? So in Python, there is something called as subclasses. Like if I do test case dot underscore underscore subclasses, this will give me a list of all the subclasses inside main, right? Now that's my subclass, which is extending the own test. So let's loop through this for class, no, CLS in, that's also might be a keyword. Okay, C. It's C. That's it. So for C in test class subclass, now what we are going to do is we are also going to find all the functions. So to find the functions, there is this standard library called inspect. So inspect dot submembers. Uh, I forgot the function now. I literally forgot that function. Oh, it's get members. Yes, get members of C. Now you get all the members of C. Let's see what's there in members. And each member will have a member name and a member object. In members, let's print this and see what's there. Member name and members object. Woo, that's horrible. So in long-winded way of saying this, it has everything like built-ins, any stubs, anything that is underscore methods, everything that's there as a part of the class is there. So let's filter that out. If member is callable of member object, we only care about functions, and is the member name starts with test, we only care about those members and we are going to only call those members. Okay, now we have, oh, thank you. Come again? Oh, see, this is why I need you guys. Member object, cool. Yes, those are all the test functions. Now we have the test functions. What is next? We just have to call it. That's it. So let's create a class. And this is, now that I realize it, this is where all the setup can go, but still not there. So let's create the class object, which is our instance. And then to the function, which is your member object, let's pass the class object, which is yourself. And we are calling that function. It's running. It's printing something, but we still don't know whether we are a success or a failure, and we're not tracking it. And that's just a matter of tracking it. So let's go ahead and track it. Success equal to a dictionary, and failures are a dictionary. Let's track it such that every time there is an assertion error, we are going to capture it. Except assertion error, failures of member name is equal to, and we have to capture this exception, right? Someone has to know what went wrong. Let's keep this exception, and if not, successes of member name equal to, I don't care about successes, let's make it none. You can also do hurrah, that worked, everything. And let's also make it more interactive, like running test case with test case name, and which is our member name. Oops. Cool, it's running a bunch of test cases, still not printing anything. So let's print it. I'm just going to print successes equal to length of success. Print failures equal to length of failures. There we go. All the successes, all the failures right there on the screen. All of that not done by Pytest, not done by unit test, but by our library, the one that you and me built right here. So in a long-winded way of I hate ChatGPT, for this whole talk, I've typed every inch of code by myself. None of the ChatGPT was exposed to it, but it can write something like this. But here we are, our own unit test with our own unit test-based class, assertions, subtests, running them with Pytest, running them with our own unit test. All of that can be done in a matter of 50 minutes. It did take some research. The code is again in my repository, pushed yesterday. You can find everything here, especially the conf test. It's very interesting. Go look at that. Uh, why should we even care about doing something like that? We're all programmers, right? Remember the first time you wrote a program in a shell and it gave you an output, it gave you a kick, and then came factorials, then came graph algorithms, and then at one point all of these problems become very simple, easy, and you don't get that kick anymore. And keeping that kick alive is part of being a programmer. And I think that's why you should do it, because you can now. And it absolutely makes you a better engineer. I've been writing Pytest for last 1.5 years extensively like a maniac, but only in the last 2 weeks I have learned so much more than what I used to know. So it definitely makes you a better engineer. And most importantly, we can all have fun. We can all have the kick. And if you want to have more kick, join the learning dev. Follow me at Bhavani Ravi _, and I'm open for questions and right on time. Yeah, if you have questions, can you come to the right side of the room so that someone can give you the mic?
Hello. Yeah, this might be a silly question, but how did we take care of setting up the class when we were using running it using Python?
Setting up the class? How did we
The
do
setup class method.
it? Yeah, because we hooked it to the init.
Oh, the init was still there.
Yes.
Okay,
Yeah,
I
yeah,
missed
yeah.
that. Yeah, thank you.
Would you run this in production?
Absolutely not. Absolutely not. Then I have to maintain it. I don't want to do that. Have you tested in prod? As in? I don't get the question. Mhm. No, but early in my, when the first year of my working, I actually went into production DigitalOcean and changed the code right there and restarted the server. Done that. Cool. Thank you all for being amazing. Before you all